Welcome to the project demonstration of solar water heater by using inverter section. So here we are going to provide the power supply to this rechargeable battery from the 12 volt solar panel. So which will provide as a 12 volts DC output, and that was given as input to this charging battery through this charging circuit. And after that the 12 volts 4 amps battery power is given as input to this driver circuit. So here this driver circuit main purpose is to convert that 12 volts DC to 230 volts AC power supply in order to make run our water heater. So the main application of this project is, so it will be useful for the soldiers or in winter seasons, any travelers, those who want the heat water. Then with the help of this renewable source from the solar panel, we can charge a battery, and from there whenever you want the hot water, then just by switching on this driver circuit, the water will get heat up, and we can see the live temperature using thermometer. Right, so on this thermometer we can see the temperature. So when we on this, if it's come show the degree Fahrenheit, so now it is degree centigrade. So just on like that, continuously hold, so you can change the unit. Right now it is degree centigrade. Just I'm placing that inside the water to get the live temperature of this particular water after heating on. And the next, coming to the working operation flow. So we gave not only solar panel is used to charge a battery, we can charge a battery with help of 230 volts AC inputs whenever there is no sunlight is available. So as you know that, as we discussed, it will be useful for soldiers and in winter seasons. If is there any power sunlight is not available, then with the help of this transformer also we can recharge the battery just by providing the 230 volts AC input to that. You can see the light indication on this charging circuit. So if you want to charge a battery from the solar panel or a transformer, so it will be fully charged in a duration of 6 to 8 hours. So that's very important. We should keep the battery charging at least of 6 hours, maximum of 8 hours. So on this charging circuit, so there is a rectifier circuit and a capacitor, and after that the DC given as input to the battery, and this is the transfer charging circuit for the solar panel. So here the rectifier also is there. As we know that the rectifier will convert the AC to pulsating DC, but when we are providing the DC input from the solar panel, this rectifier will act as a polarity corrector. Means if we connect the solar panel in reverse bias, because our DC power supply has a polarity, so if you connect the reverse bias, then the battery may get damaged. In order to protect that, we need to correct the polarity by using this rectifier IC. So rectifier IC's main purpose is convert AC to DC, right? So if we providing the polarity reverse also, it's nothing but minus plus plus minus, means alternating current. So that will be converted into the direct current after this, and through capacitor, through the diodes, we're going input providing the input to the batteries directly. So here the diodes are used to making use of unidirectional current flow. Means whenever the battery is fully charged, in order to protect the solar panel, we are going to block the current flow from the battery to the solar panel. So that's why we place the diodes here. After the battery is fully charged, means after 6 to 8 hours completion, just you can disconnect the transformer. And now, so this is the main on-off switch to making use of our heating circuits. So coming to this driver board, there we can see the around 2 MOSFETs and 1 regulator and 1 step-up transformer. So these MOSFETs are used to convert the DC power supply to the pulsating AC power supply to 12 volts. So means 12 volts DC is the input to that circuit, and after this MOSFET we will get the 12 volts AC output. So that will be step up to the 230 volts AC, so which is the main operating voltage of our water heater. So that will be done by this step up transformer. So means 12 volts DC input to the circuit, 12 volts AC output from this MOSFET to 230 volts AC output from this transformer. So let us see the demonstration. So as of now the temperature is low, so water temperature is 37 degrees centigrade, and now I'm going to switch on this. let's wait till the water is getting heat up. So it will take some time to heat up the water. So right, so the temperature is slightly increasing, we can see that. Right, 35.2, 35.5. Right, slowly the battery voltage will be converted into the DC to AC, and we can get the temperature increment also here. Right, right, now it is room temperature is 32.4 degrees. So now it is 36.8 inside the water, 37.1. So it's keep on increasing. So slightly as we know that once the heater gets start heating the water, so initially it will take some time. Once the heating was started triggered, then it's increased rapidly. Right. So in this time, so the temperature of the water increased from 32.4 to around 38 and keep on increasing now.